Welcome to Ideal Clamp Products, headquartered in Smyrna, Tennessee. For over 100 years, our core competency has been hose clamp manufacturing and engineered clamping solutions for virtually any industry requiring a clamping device. Today, the Ideal Tridon brand is globally recognized as a leader in clamp design, product quality, manufacturing, and technological leadership. In 1965, following the introduction of hubless cast iron soil pipe and fittings, the company designed a mechanical joint to be used to connect these hubless configurations. Ideal aligned itself with the largest cast iron soil pipe foundries of the day and became their private label supplier of standard duty couplings for decades. Literally millions of Ideal couplings were sold under the foundry brands Tyler Pipe, Charlotte Pipe, and AB&I as a part of a DWV system that would last for the life of the structure. Today, Ideal markets our line of couplings directly to plumbing wholesalers under the Ideal Tridon brand. With this change, we bring the same reputation for quality, reliability, and durability that was built decades before as the private label supplier to the cast iron soil pipe foundries. Which brings us to the focus of today's presentation. What you're about to see is a time-elapsed representation of the 3 performance tests we conduct as outlined in the ASTM C1540. This is the performance specification of heavy-duty shielded couplings joining hubless cast iron soil pipe and fittings. The 3 tests measure coupling performance under deflection, shear, and the unrestrained hydrostatic thrust pressures. In the interest of time, we have limited the tests to 6-inch and 8-inch heavy-duty green shield couplings only. All the tests were conducted at Ideal's laboratory in Smyrna, Tennessee, and were witnessed by an independent third party who certified the results. Thank you for your time, and know that we welcome your comments. Now for the presentation. After preparing the test setup, a coupling is installed between 2 pipe segments with closed ends. The coupling is torqued per the manufacturer's specifications up to 80 inch-pounds. The apparatus is then filled with water, the coupling retorqued, and the displacement gauge zeroed. The test is ready to begin. The pressure is set to 1 psi and increased by 1 psi after every 30 seconds until the specified pressure is reached. This is 27 psi for a 6-inch pipe. The pressure is then held for an additional 15 minutes. Any leakage or axial joint movement of more than 150 thousandths of an inch shall mean failure. For the shear test, a coupling is installed between 2 pipes with closed ends. The shorter pipe is affixed to a platform, while the longer pipe is supported at its far end. The coupling is torqued per the manufacturer's specifications up to 80 inch-pounds. The apparatus is then filled with water, the coupling retorqued, the dial gauge zeroed, and finally pressurized to 8.6 psi. 50 pounds per inch of pipe diameter is loaded on the long pipe next to the coupling, creating a shear load. For the 8-inch pipe, this is 400 pounds. The 8.6 psi pressure is maintained 15 minutes. The coupling must not leak nor displace more than 3/8 of an inch in order to pass the test. For the deflection test, a coupling is installed between 2 pipes with closed ends. The shorter pipe is affixed to a platform while the longer pipe is supported. The coupling is torqued per the manufacturer's specifications up to 80 inch-pounds. The apparatus is then filled with water, the coupling retorqued, and finally pressurized to 8.6 psi. The far end of the longer and unrestrained pipe is raised 1 inch for every foot of the pipe's length. For a 5.5 foot pipe, this is 5.5 inches high.